I'm joined today by Jelle Feringa, construction automation serial entrepreneur and trailblazer. How's it going today?
Terrific. Good to talk to you, Jared.
Yeah, I want to talk about your multiple ventures in construction robotics, but I'm really curious what got you into this field, which you've been pursuing with multiple ventures at this point. What did you recognize that led to this pursuit?
So my background is more in fine arts, right? Mm-hmm. So autonomy is there's no fine arts without autonomy, you could say, right? And in architecture, you have to relate to a client, to a building contractor. There's many various constraints imposed, and for a long time I had the architectural practice, Easy City Architecture and Design Research, together with Philippe Morel and Felix Agit. Maybe you know them of X3, also one of the pioneering 3D concrete printers in Europe. So after a number of years of running an avant-garde practice, it was also hard to sustain that practice. So we have both, let's say, an architectural practice that builded projects, and it was difficult to, let's say, merge the research we were doing under the flag of the practice with the more traditional architectural practice, right? So there were two somewhat parallel tracks, and we saw robotics as definitely a way to merge these two fields, right? All of a sudden there was this kind of ideal interface. So both in terms of on a material level, but also on an intellectual level, that, you know, if you can compile robotics code, it's actually a bit more interesting than defining your architecture through plans and sections, right? And I feel also that this was also in a time when architectural practice was being more and more marginalized, right? So with robotics coming into view, let's say both artistic merit and also economic leverage can be, I think, ameliorated at the same time. So that's incredibly attractive, right? And yeah.
So before X-Tree, your life wasn't dedicated to construction robotics. What kind of fine arts were you involved in?
Let's say from fine arts, I mean, I see architecture as a part of fine arts, right?
Absolutely.
So we had the Easy City practice from around 2000, and I was involved in it until 2007, 8, around that time, and I had the good fortune to start a PhD research around that time, which gave me the opportunity to delve into robotics. So yeah, and I've always been an autodidact, with a PhD. Mm-hmm. But that was a phenomenal time at the Hyperbody Research Group, led by Professor Cas Oosterhuis. Yeah.
So that was prior to meeting Felipe.
No, Philippe, we met back in 2000,
Okay.
2001. Yeah. So we've been lifelong friends and partners together with Felix Agit. Yeah.
And at what point did you become an advisor to X-Tree?
I'm not really involved in X-Tree. So when I was heading for TU Delft to pursue my PhD thesis, I went subtractive, pursuing hot wire cutting, while Philippe and Felix started to work on X-ray and the 3D concrete printing.
So more parallel rather than.
Yes, yeah. This was around. This was around 11, 12. Yeah, so pretty much in parallel. Yeah, correct.
You were at one point involved in a 3D printed construction company and still serve as the advisor to Actual.
Correct. Yeah. Yeah.
But before that, you had another venture, EZCT. That was the firm you were talking about from 2000 to 2008,
Yeah.
primarily.
Right. That's the architecture practice. And then after the sort of when I was halfway into the PhD thesis, I also had that feeling that sort of in academia, PhD is the greatest position, I feel, in a sense, right? It comes with so much freedom. And so around halfway through the PhD thesis, I set up Odico Formwork Robotics in Odense in Denmark. This was a direct result from presenting at the Fabricate 2011 conference. So this is already quite it's more than a decade, well
Okay.
over a decade. Yeah, yeah.
And the work you presented at that conference using subtractive manufacturing robotics, how did that lead to the next venture?
The interesting thing is that sort of we're used to speaking in terms of additive and subtractive when discussing the realm of digital concrete. But there's something futile about it, right? I mean, if you're making molds subtractively by hot wire cutting, and you pour in the concrete, it's a bit ambivalent whether you should see that as subtractive or additive
True.
manufacturing, right? So I think, let's say, being practical rules, right, especially in challenging worksite conditions. But long story short, in a sense, right, is that I felt I had quite a bit of experience CNC milling, and it was obvious and clear to me that that it was prohibitively costly, right? Just in terms of the output volume versus the cost and maintenance of running fairly exotic machinery, right? So I think the enthusiasm of industrial robotics was also that they were relatively affordable. So I managed to get a hold of a number of quarter-century-old ABBs. The first that came with the rapid language, and for scrap prices, basically, like nothing. And it sort of relaxed the atmosphere at the robot lab, because since the costs involved wasn't that high, there wasn't also a vast pressure to get results. While we actually initially managed to do so. So what was very important to get up and running was also, which came about of the Fabricate 2011 conference, was meeting with Dave Pegram and Wes McGee, and that helped kickstart the momentum of the lab. So Wes and I were both interested. We both presented work regarding hot wire cutting, but Wes McGee was a half a year ahead of me in terms of developments, and a far cooler dude.
Well, from architecture, at least American architects I've spoken to, it seems like in architecture school they try to get you to conform to traditional styles of architecture and build classical styles, but the technology you were working on is in theory enabling the digital modeling, which was previously cost prohibitive to construct. It makes it possible to build. So is there a specific kind of design you were seeking that was enabled?
So I mean, I think that hinges back into why with Easy City we developed such an interest in robotics. So following, we won the Sarusi Gallery competition back in 2007, and architecturally I felt in sort of Olympic form, to be so immodest. And it was frustrating as an architect to have relatively little control in terms of the economics of your build proposition, right? You're leaning so much on what a building contractor is coming up.
Mm-hmm.
So in a sense, if you're doing run of the mill stuff, then you're gonna your prices will are a bit more indicative. But if you're architecturally a bit more explorative, that uncertainty also scales accordingly. So actually, it also made sense to get into fabrication, and maybe on a deeper level, I think architecture is a simultaneity of design, economics, and craft, right? So you have certain design that is overly crafted, right? Is obsessed about that, obsessed about some kind of handiwork, or some design is just too designed and it ignores industrial and other constraints. So this to achieve this simultaneity between these various aspects in architecture is an absolute challenge. And I guess I this intuition of hot wire cutting stemmed from that. So it was kind of tied to a material strategy as well, following from expanded polystyrene foam blocks. So you can recycle them very well. What's also interesting in that material is that it's incredibly so we can establish that it's not very bioorganic, right? Is that it's not a bio-based way of building. But let's say the few liters of styrene, it would result, it's actually quite effective if you look at that a bit more holistically, because it has such a great insulating capacity that that trade-off is actually quite cool. So at that time I was thinking that this combination of a methodology that, let's say in terms of formal grammar allows a great scope with this very cost-effective and high insulating capacity of the EPS foam was kind of a fantastic package. And since EPS has this amazing property of being able to hold up a lot of pressure and vast amounts of hydrostatic pressure, from there on, kind of mold making emerged as a kind of logical natural conclusion, right? Economically. So also there, in a sense, right? Initially, my thought was more to use these EPS elements more as plugs than as molds, more as positive forms rather than negative forms in which you cast the concrete. So again, is that it's interesting, right? The normal of the surface, right? If it's a positively defined shape or a negatively defined one. Yeah.
So when you start working with these robots, were you mostly responsible for the design side and there were other team members who were handling the software, or were you jumping right into managing the software yourself?
Managing the software myself, definitely. And that also wedges into Easy City, actually, because in a number of, at the time, around this time of 2008, Digital Project, this branch of CATIA, was quite popular in Paris, and it was phenomenal software, and there was also a consultancy service, engineering service tied to that. So a lot of the intelligent, clever people ended up in that realm. Did really well for some time. And we were pretty interested in exploring CATIA, and there was writing Python code in the backend together with a friend, Thomas Paviot, who created a rigid body dynamics plugin. Kind of surprising that CATIA didn't have that. And at some point we were informed to either pay up a plugin development's license or stop pursuing that particular vector. And from then on, Thomas took the initiative to develop Python OCC, which is an open source CAD kernel. And that seemed an incredibly attractive project to pursue. Since I very much like, from Easy City, our view on the world is very much a computational one. So let's say I was keen to have a Python kernel without any GUI attached to it, and so something closer to the metal, so to say. And that also, why am I digging into this? That also was the essential underpinning for the PyRapid software that we used for Audico. So somehow these various avenues kind of do correlate strongly in a sense, right? From projects tangentially flowing from one into another. Yeah, and I mean that software is still quite strongly maintained and making quite a few waves. It's the same underpinnings as FreeCAD, for instance. And Tom van Meel of the Block Research Group is recently also became quite a fan and is developing on it. So it's exciting to see. Yeah.
What was that learning curve like? Were you taught in school Python, or was that something you had to learn on your own afterwards?
No, so I didn't study that much, I have to say. I did spend a few years in the art academy, but architecturally and also in terms of technologically, both in software development, I'm autodidact. Yeah.
What was that learning curve like? I mean, it's not easy to just jump into no GUI Python.
No, very, very steep. But also liberating, right?
Mm-hmm.
And in a sense, you develop an instinct for the development of certain technologies, right? Is that sure the investment is considerable and steep, but softwares are cultural entities, right? So in a sense, if you go along, I think choosing the kind of software, it determines your world to a large extent, right? So it is something that you can invest deeply into because it will have profound effects. And so when I started to join Thomas Paviot with the development of Python OC, I didn't have Audico in mind, but it would have been difficult to pursue Audico and pursue robotics without a powerful CAD kernel. So I'm a huge fan of what the Block Group is doing with Compass. I think that's since Grasshopper a very, very significant development. I never was a fan of this visual programming, mm-hmm. And I think I had these kind of similar ambitions, but not as technically competent and as well organized as what is coming along these days. So I think that is a incredible effort, and significant because I think it's the best way to condense your research, right? Is that if your research is executable, if you can share it in an open source manner, it will continue to evolve. So, when we were working on sort of the seminal projects of Easy City are very much onto evolutionary computing, right? Is a kind of very conceptual approach to architecture, where you try to have a clear architectural concept, frame that into code, and accept its outcome in a sense, right? So we're running these large evolutionary computing programs on grid computers at the INRIA research facilities at the in Paris, and working with the top researchers at the time, which was an absolute privilege and very, very interesting. So in that sense, it also came natural in a sense, right? Is that the development of such a kernel seemed logical.
Yeah, I'm a firm believer that intrinsic motivation, especially for knowledge and skills, is much stronger than external motivation. And so if you are learning things because you want to use them and you have specific use cases in mind, it's, I don't know, a much stronger motivation. And it's easier to stay driven and passionate about what you're doing. So that seems to be something you implemented very effectively. When did you then join?
Well, effectively, it was also hard work in a sense, right? It was also somewhat naively in a sense, right? So, but it had its merits, right? So at the time, I had little idea about how many years would have been involved in those projects. Yeah.
Certainly. Yeah, I don't think it ever comes without the hard work. The actual, you move from the wire cutting to concrete printing. Which of the skills you developed prior were they most in demand of at Actual?
So with Actual, we use more fused deposit printing rather than specific. It's not tailored around concrete printing per se.
Mortars,
so
plastics.
sort of exactly. The product we're known for are these printed terrazzo floors. So in a sense, it's more the mold that we are printing than, and the infill is installed on site in situ, and then after milling out the surface, these beautiful patterns emerge. And what I think is what was interesting with Actual is that in Odico, as makers of these molds, we kind of at the time ended up as a subcontractor. This is a couple of years ago. It has changed a little bit over time, but when I left the company, we were kind of subcontractors. And what I think is cool with Actual is that we're through the technology that we're building, we're consuming that technology ourselves in products that are hard to replicate in a sense, right? That are tied to the methodology that has been developed. So I think an interesting aspect of the success of Actual is this a new view on what an architectural practice economically may pursue, right? So new kind of model for an architectural practice, and
Would most clients approach you wanting a creative design, or do they have some design in mind that they want to bring to fruition?
I think both and so I think of the products that we pursue with Actual are very much open to extension. So the initial version of the floor was designed by ourselves and installed in Schiphol. But also it's open enough that a famous designer like Patricia Urquiola can project her design language on top of such a product. And you know what is that in architecture, Since the credit crunch, the average size of an architectural practice is 4.3 FTE. Right? It's really, how can you have a serious impact if all of these, so many of these offices are of so modest size, right? And I think that has something to do with also a little bit egos in a way, right? Is that in order to make yourself known to the world, I think it's impossible with four people in a sense, right? Because you just don't have you just don't have enough personnel to really. If you're not pursuing a niche, then architecture is too demanding to develop something novel. So then you have to compete on sort of a brand name. I think it's just a disaster, right? I don't think it's going to work. So that's why maybe you also had a little bit more of an open mind that it's also important if you don't want to be if you want to overcome this problem of this danger, maybe that's a better phrasing, of becoming a small marginal office, that that's actually a requirement to make these products also open for extension. So I like that kind of attitude in a sense, right? Both niche and open. It's somewhat paradoxical.
Yeah, and a floor is a great place to be designing something so custom because it gets so much traffic, and it's especially if it's a unique floor. It's pretty rare for somebody to walk on a floor and it be something they've never seen before, or totally unique. So I could imagine that bringing in lots of new clients after they see the product and asking, who did this?
Yeah. I mean, it's an interesting story because Actual is a spin-off of Dus Architects, and at the time, Dus was working on 70. This from the Kamermaker, right? From one of these first 3D printers of the building at the building scale, and working on 70,000, a renovation of Schiphol of 70,000 square meters, and basically. Wow. It's really difficult to fiddle with the light or think of a specific texture for a furniture piece when anything you do is swallowed up by an ocean of bland gray tiles, right? So there was a need for us to think of a foundational, a new foundational entity, right? A new foundational product, and that became the printed floor. But it's kind of interesting, right? Is that it does open up these floors as these vast architectural canvases. And back in the day, a very important exhibition was held at the Centre Pompidou in 2003, the Non-Standard exposition curated by Frédéric Miguerou. And Easy City produced the layout of the exposition, the scenery of the exposition, and also there we installed one of these very bespoke floors. So it's something that I've dabbled with for a while. But at the time I was also very lucky to be involved in Actual. So much work had already been done in terms of financing. There was a beautiful building, a beautiful workshop already set up. So the team of Dus had already done a lot of work before I came into view. But we're also a little bit behind on the 3D printing technologies. And with the experience of being knowledgeable of robots actually meant that we could develop it fairly quick. I think it about took 3 to 4 months, and then up to half a year before the production was really streamlined, and then we were running prints through the night. So that's something very enjoyable of being able to pursue this lights out mode of operation. So there's there's 24 hours in the day, and you spend 8, such that you have 16 hours of productivity, if not 24. And after half a year, we routinely ran print throughout the weekend, throughout the night. So there's something pretty cool about.
You'd trust the system to run without anyone there?
Yeah, sure.
Wow.
Yeah, it's routine, right? So after half a year, it was routine for it to operate lights out. But you need to, right? Is that if you're doing FDM printing, you're basically watching the paint dry. So it's a requirement. So initially we optimized for deposition rate. We're a little bit too focused on that, trying to print 25 kilos an hour, which is a lot in FDM. Of course, there's nothing in concrete printing, but in FDM that's a bunch. But it's actually more the robustness that is essential, that is critical to be able to, that you can go home with confidence and have beautiful products in the morning. So
that's unheard of with concrete.
Yes, but concrete is also, you're printing much faster. It's much more susceptible to conditions, right? So, if your environment changes, the temperature, humidity, I think you'll be in. So you need to have to. Of course, you can program a PLC to see if you can adapt those conditions and stop your print when it becomes unstable or something. But also the flow of material, it's quite challenging. But with terrestrial, is that I'm definitely pursuing this kind of lights out mode of operandi. I think that it's defining for the economy of robotics. So what's interesting is that if you consider the day not as 8 hours but 24, it becomes, you cater to the needs of the production such that you make sure that you have another 16 hours of productivity, and actually at some point you become the overhead. You see what I mean? And so in a sense you stop losing money when you go home. There's it sounds maybe a bit cynical, but it's also kind of fun if you manage to achieve it.
Yeah, absolutely. I want to get into the block foundation and terrestrial. Before we do that, I want to let you finish. I think we have like a delay in the thing. So I want to let you finish whatever you were just saying, and then I want to ask about the credit crunch that led to the 3 to 4 people in each firm. Was that after 2008?
Yes. Yeah. So architecture firms. Well, this is specifically for the Netherlands. I don't know how the distribution looks like in Europe, but I wouldn't be surprised if it would be around the same distribution. So before and after the credit crunch, I think there were 150 offices in Amsterdam and 1,500 after the credit crunch. So that's order. Yeah, it's bizarre in a sense, right? Is that you can't compare the economy of architecture office before and after. Yeah, severely.
And then the credit alleviated, credit rates went back down again, right? But the number of firms stayed high and kept growing, or that never consolidated?
It never consolidated, no, and still hasn't in a sense, right? So it's definitely a different reality. Yeah, It's fascinating, no? When you think of it,
yeah. I'm always trying to understand how the world works and the macroeconomics. It's so it's almost impossible to understand, but I still like to ask questions when I can.
No, but I think that's very interesting in a sense, right? And I think in architecture, I mean, it's so driven by economics, and in schools, it's not taught, right? It's that just discarded. It's shocking, right? And because I think you need to see the economical in and outputs. Those are design criteria, right? And it's not something to be scared away of, but addressed heads on. it rules our world so considerably, and yeah.
What were you getting at before that? Before I took us off in a tangent.
Oh, sorry. I missed it, Jared. Help me out, please. What was that?
Well, let's move on to the block foundation. So, from actual, you had mentioned to me you kind of have a startup mentality and you like beginning new ventures and starting companies. So, was that something burning inside you that you were eager to create something new after actual had kind of grown to a sustainable point?
Mm, it also has to do with character flaws. Is that, when Audico became more in an operational mode, when the fundamental software technology was developed, I'm not comfortable with an operational with managing operations, right? I'm just not. I get in the way, and I think to some extent that applies to both Audico and Actual, right? Is that I feel that I become a bit jittery, and that it's time for something novel. Yeah, yeah.
So, what was the birth of the Block Foundation? Was there a moment that you had an idea, or was there an inspiration?
Yeah, the analysis is that, after having spent a decade in robotics, I get into this somewhat of this paranoia that you might up producing similar design with different means, right? And if you don't change how architecture is financed, that, let's say, the impact in terms of fabrication is also limited, right? You need to control. You need to be able. You need to pull from either end of the rope to really have some control and to really put forward interesting propositions. So that's why I think the design of your practice is so often somewhat underrated, right? The architecture of the kind of firms that you're pursuing, and I guess is that I'm quite and that's definitely not only my contributions. It's the team of Dus Architects, of Hedwig Heinsman, Hans Vermeulen, Martina de Wit. So together we truly re-architected architectural practice in Actual. And I think that's an important contribution. And let's say with Audico, I think, let's say, the design on an economical level maybe was a little bit flawed, right? Is that ending up too much as a subcontractor? I mean, the company is pretty successful. It's the first publicly traded architectural robotic firms, and I mean that's quite cool. But the ties to architecture are closer with Actual than with Audico. Audico is closer to construction, where Actual is closer to architecture. Yeah.
So now we get to your Terrestrial, which is in doing earthen construction. And it's clear to me that you've prioritized economic viability, which is great, and something that a lot of people from a design background tend to overlook. They create incredible renderings, and then they don't think about how it could actually be built, and they end up never getting built. So how are these values represented in Terrestrial?
I was a rendering specialist for a long while. So, well, so in a sense, I think the outlook on earthen constructions was was also driven that just by the dumb fact that there were already at the time so many 3D concrete print startups, right? And I'm friends to some of the prolific ones, right? X3 with Philippe Morel and Felix Agit, but also Vertigo with Volker Ruitinga. And I mean, they're doing a killer job, right? I mean, so I was fascinated with concrete printing, and I dabbled with it in 2015. I mean, did pretty okay, but nothing. I didn't have a radical view to offer, right? And then you're competing with the rest. That said, so being in awe by X3 and Vertigo. So my Terrestrial's next door neighbors with Vertigo. We are very close. But after a number of years, I also saw and observed a couple of downsides of the of extrusion-based 3D concrete printing. You know, is that when we speak of concrete, it's the marriage, the composite of steel rebar and concrete. And in a sense, if you look a little bit critical at concrete printing, it's more aggregate is missing, obviously, right? I mean, rarely you see anything more than 2 millimeters. And, you know, technically in geophysics, anything smaller than 2 millimeters is considered sand, right? Is that above 2 millimeters is considered aggregate. So there's hardly any aggregate in it. Well, if you observe the composition of concrete over well over 100 years ago, it's sort of cement bonding aggregate, right? Is that so? Let's say what we think of concrete is not uniform, right? That's pretty interesting. But you know, the incredibly high content of cement, not being able to work with rebar, I find problematic. So I think, yeah, a new outlook on printing was necessary. So in that sense, I'm attracted to very much to earthen constructions, because with earthen construction, first of all, is that the material is kind of negative value, right? Is that if you consume it at scale, right, for one or two ton of earth, nobody will care in a sense, right? But if you do this at a massive scale, the material's either cheap or negative value. And in earthen constructions, more and more it's becoming viable to stabilize earthen constructions without the use of cement, right? So common mixtures use about 5 to 10% of cement. 3D concrete mixtures, I think it's between 35, 40% of cement is common. So you could, I mean, 3D concrete print has a problem in terms of its environmental footprint. I don't think there's denying it. And I think geopolymers, I'm also not convinced by that, you know, is that it's a shifting. It's important with geopolymers that they don't use cement so extensively, right? But it's in terms of ecological footprint, it's not a revolution when contrasting it to concrete. So that drives me very much, right? Is that the ecological footprint? The irony is that even though the materials are cheap, are extremely affordable, earthen construction is very expensive because so much labor is involved in that, right? And then don't forget that also in timber, I mean, it's fantastic what is happening in timber, but I think it's presented a little too much as a silver bullet, like it's going to solve all of our problems. So a bit too much of a reliance on timber. So that that make me very attracted to earthen constructions. And I'm really enamored with brutalism in architecture, right? So the realization that if I ever want to do a brutalist building, and I'm kind of inclined to do so, it's going to be an environmental crime. There's no denying that. It's a fact. So you could do this kind of architecture with a totally out of skew solid void ratio, right? I mean, I think that's very interesting. So there were a number of factors drawing me to that conclusion. Yeah.
And so you founded Terrestrial a little over a year ago. And when you first got started, were you experimenting with different combinations of dirt, clay, and the materials? Was it mostly figuring out how to get it pumping? Did you have robotics involved right from the get-go? How did it start?
Yeah, robotics involved from the get-go. I'm not very much of a material specialist per se, but one of the key challenges of working with clay is shrinkage, right? So a lot of colleagues in the field are dealing with this with severe shrinkage. So I mean, 6-7% of shrinkage is not unheard of. Yeah. And then, that starts to define, that becomes a constraint in a sense, right? You need to build something circular or so, or an oval, or those are forms that can accommodate shrinkage. So that was an important aspect to tackle. And our shrinkage is under half percent. So it's, we got that pretty good under control. So that's pretty key. So in earthen construction, the challenges are, just the strength of the material. Mm-hmm. It's far weaker than concrete, of course, right? Is that printed concrete 60 MPa of compressive strength is nothing out of the ordinary. And to get 6 MPa on earthen construction, it's like you're doing a fine job already then, right? So it's about a tenth of the compressive strength, if not 1/20th. Then erosion is one of the challenges, but there's a lot of literature on that, right? You can, it's relatively well understood. It's ductility, I think, is the most difficult aspect, right? Is that the material is tough. So on an earthen construction, when it breaks, puff, it goes, right? There's no ductility there. So I think that's a core challenge.
As far as mixing it and getting the material prepared to run through the robotic arm, are you able to do that with automation, or does it have to be all hand mixed?
No, that's a big one. And that's quite capital intensive. So we're designing such a system at the moment. The project that we're most focused on are these sound barriers. So that takes place at such a volume that you really want to mix the material in situ, right? That would be ideal, and so that actually. That comes with an additional set of challenges. So the mixing is it's pretty tough. Also, the deposition rate is pretty high. At the moment, we are printing between half a cubic and between 0.5 cubic meter and 1.5 cubic meter per hour, and the coming year we're bumping that to 5 or 6 cubic meter per hour, and those are high depositions rates, right? That's also attractive about it, right?
You increase that by increasing the diameter of the hose?
Yes, that is one of the aspects. That is a requirement. but 5 cubic meters is relatively doable. So we're not using an extrusion-based system, but it's much more based on shotcrete technology, and that idea has wedges back into the consideration for rebar. So it's possible to utilize rebar when in shotcrete methods, right? I mean that is relatively well understood. I'm not saying is that it's not entirely without challenges, right? So if you spray the material on the rebar, there's shadowing, right? The material doesn't end up uniformly at the on the backside of where you're projecting
different
to.
angles and stuff.
Yeah, sure, but it's routinely done, right? Is that most shotcrete constructions come with rebar. So actually, that's also interesting that it's a relatively well understood field. So with 3D concrete printing, also a lot of novelty is introduced. So it's also challenging to bring that to the market. A lot of validation has to be done. The mixes are complex, and yeah.
It has all that compressive strength, but it's, as you said, when you're extruding concrete, it's very difficult to do that around any kind of rebar structure. So it has like almost no tensile strength, which ends up requiring backfill or poured columns within the printed concrete, using it just as a formwork. And in that case, it may as well just be the foam that you're using before without the insulatory value. So it makes a lot of sense that you'd want a solution that could achieve a tensile strength. For a sound barrier, you don't require, it's not taking a vertical load besides itself. So it's a great use case.
Yeah, and the thinking is that, the processing earthen materials, I think this is more important than the material science. From my perspective, let's say from my perspective, that's somebody who's interested in promoting earthen constructions. The reason why is that it's very difficult to compress material research, right? It's very incompressible. You have to go through so many iterations, so there's no shortcuts there. Mm-hmm. And I feel that so the norm of processing earthen materials is that you put up a concrete mold, right? And you use a pneumatic hammer to temper the material. Right, exactly. And you build up layers of 15 by 15 centimeters layers of material. So it's, you can't argue that it's super old school 3D printing, right?
Tremendously labor intensive.
It is. And I think that's the pain point, right? So if you want to popularize earthen construction, and I think there's a tremendous urge in doing so, you need to address labor heads on. So the cool thing is that if you can print it, you don't need any molds, right? And I think it would be amazing if we can achieve lights out earthen printing in a couple of years from now. Fingers crossed. It's quite a challenge.
It's a good goal.
Yeah.
I almost never even hear concrete companies talking about that goal. With concrete, it's so hard to achieve. It makes such a mess, and it's so permanent if you don't fix the mess immediately. But with earthen construction, worst case scenario, you grab a shovel and you clean it up the next morning or a week later.
Shoveling is definitely part of the equation. We use a dry mix approach. So in shotcrete, you either go wet mix or dry mix. With wet mix, you can achieve greater volumes, but then it's a lot more stressful due to the setting of the material. And if you're printing with dry mix, if it's 12 o'clock, puff, stop the printer, lunch, right? No problems. And even you can restart a print from 2 weeks ago. It's totally continuous. So that is there are some very interesting properties there. I was completely bewildered when I saw that for the first time, that we could just kind of endlessly start and stop this process. So it's fairly mellow in that sense.
Yeah, that's much better than the double bond epoxy layer that they need for concrete after they have a solid to avoid a cold joint. That's expensive, labor intensive, all those things. So in Europe, is there past precedent for permitting buildings created with earthen materials? Is it all around rammed earth?
Yeah, so actually my friend Diederik Veenendaal, who's one of the absolute top engineers of his generation, he set up a company called Summit Engineering here in Rotterdam. So I'm super lucky because I also live based there. And Diederik worked for half a year on compiling all of the bits of code from New Zealand, from Germany, from France. So we have a very strong grasp of building code related to earthen constructions, and that helps to fill in the blanks because it's definitely lacking. Yeah.
Europe has such a stronger history of construction innovation than the United States. I think a big part of that has to do with permitting. And also, I know in the north it gets so cold they have to build in such short time frames that they've been innovative with prefab solutions. So have you municipalities been receptive towards your approaches of earthen construction?
Yes. So we're working now on developing a proposal for the municipality of Eindhoven. So at the scale of sound barriers, we're really a technology startup, right? We're piecing together a package that the building contractors will utilize. But on the scale of houses, I think it's too early to share such a package with third parties. So the coming year we're endeavoring on building a house in Eindhoven. Yeah.
Wow, that's huge. So you do have intention of creating residential structures very soon. Europe has such a rich old culture. I'm sure there's old buildings like 500 years old made of earthen construction, right?
Yes. So a number of years ago, I worked on diamond wires following natural stone, and the project was kind of well received. And I feel the reason maybe that it's kind of equivocal, right? So for the traditionalists, there was natural stone. For those progressive technophiles, there were robots, right? And maybe printing earthen constructions has this similar kind of ambiguity, right? Where it's both incredibly progressive and somewhat regressive, maybe even. Yeah.
Eindhoven's a hot spot too for a lot of architectural innovations and design. Have you been able to lean on that community? Yes, you mentioned your friend who compiled all of the permitting around earthen construction, and you're right next to Vertigo and Volker. He's great. Are there other ways the Eindhoven community has you benefited from being in that region?
I'm not sure yet because I've been, Terrestrial has. I'm not sure how you dug us up, Jared, because we haven't disclosed that much information so far. So, with a little bit of luck, we'll be involved in the upcoming Dutch Design Week. But the honest answer is that I haven't dabbled enough. I haven't engaged enough in that community to be fair.
I'm sure once you start doing more physical projects and the sound barrier in the houses, they'll come to you. So
Fingers crossed. I hope so.
I'm sure they will. It's going to be an awesome project, and there's something special about regressive sounds like the wrong word, but technologies that revisit, I guess, origins of construction or historic methods that people used, and they always seem. It's funny how things come full circle, and all the technology ends up being used to build the same thing that they were doing so long ago, potentially. But the project that you won the award for in 2007, what did that look like? What had you built?
Whew. It's challenging to describe. Let's see. Can I share my? Is it welcome to yeah?
Please.
Jared, help me. Are you getting this or?
Not yet. There's a button next to the leave button. It says share. Mark, clip, mic, cam, speaker, share.
How is this? Yeah, I'm seeing the button, but. So I'm afraid I need to restart my browser in order to get that up and going.
Are you using Chrome?
Brave, yeah. Because I can't hit share somehow.
Yeah, I think it's because it's not Chrome. Do you have Chrome?
Brave is a Chrome browser, though, right?
Okay.
It's technically the same underpinnings. Shall I send you a couple of screenshots otherwise?
Yeah, I can add it in.
Otherwise, edit in?
Is there something I can Google just to get an idea right now?
Oh, sure. I'm looking for the chat window here, but there's none, is there?
Yeah, it's top right.
Okay, let me find you something. Yeah, here you go.
Oh, wow. That's incredibly unique.
Oh, thanks. The design is adolescent. It's 14 years old, right? I mean, it's half a professional life ago. Yeah, but I think it's some of the impetuses of X3 and Odico can be retraced through winning and not building that competition.
Yeah, I'm sure there's really unique, like different times of the day, the shadow shines in such unique ways, and it's not just like a plain square window. There's so many curves and shapes. It's almost like a new building every hour.
No, it's interesting that you mentioned that. So the idea for this gallery was that, so it's very much driven by computational architecture, by evolutionary computing. And when I started with architecture, I was a rendering specialist, and I used Radiance, which is a physically correct, photometrically validated light simulation engine. So it also runs on these massive grid computers. So the thinking is that functionally it's entirely reasonable to ask for a window of 300 lux, right? But an architect would find that an absurd way would find it an absurd amount. And also for a gallery, is that if you have greater than 300 lux of light, it will deteriorate the artworks, right? So the evolutionary computing process sought out to resolve the program of the building in such a way that the gallery would be lit by 300 lux throughout the whole year, throughout the whole day. It was kind of that was the original design concept.
That's fascinating. And so when you are trying to achieve that 300 lux, is that done? Does the computer give you a model and say this is 300, or you had to through trial and error do testing and simulate the sun moving around?
Through trial and error, yeah. Excuse me. Yeah, definitely. So it took 3 months to compute. Yeah.
Wow. Okay, cool. So back to Terrestrial. You started that company. Your LinkedIn at least says a year and 3 months ago.
Yeah.
Did you hire a team immediately? Were you working on your own for a while?
No, on my own with a couple of interns and a cool group of people are flowing in and out. And also, I think, let's say, in those initial phases of the company, actually, it doesn't help to be with 10 or 20 people. Now that after a year we have a grip on the fundamental technology, and now it's time to scale things up, but only after about a year and three months. It takes some time, right? Is that yeah?
So are you looking for your first hires now, or have you made, besides interns, a first full-time hire at this point?
Yeah, we are scaling up the team at the moment. Yeah. Yeah, also because we're working on quite a number of projects, but I also had great luck that Jori helped me out tremendously the first year, and so his graduation project really overlapped with the kind of technology that we're pursuing, even though NDAs were installed at the time. So I also have been having very good luck with those coming to help me out. Yeah, for sure.
Were you able to get funding through grants, or did you have to self-finance everything to get started?
No, in Europe it's relatively, there are a lot of grants, and especially with climate change and how the built environment is such a dramatic player in that. Is that it's quite a number of grants are available, and that really helped for the first year. Yeah.
So now that you're looking to scale up, what roles are you most in need of?
Mostly material research and refining the print technology. Yeah. Mm-hmm. So PLC, hardware, software. Yeah. Controller
if somebody's
software
listening
on
and they're really passionate about everything you're talking about, and then earthen construction, and they want to work with you, what's the best way for them to contact you?
Through my email. Let me share that you on the screen.
Your Gmail?
Yeah, please reach out. Sure. Yeah.
JelleFeringa@gmail.com. I'll
That's
put
right.
that in the description of the video too.
Terrific. That's huge, Jelle.
Yeah. Hopefully someone's listening who's interested. I like to think I have an audience of passionate and intelligent people. Maybe one of them is in Eindhoven. So Do you interact with Vertigo and Volker often? And you work in the same area, so you see them all the time.
Practically on a daily basis, and we have lunch at the same hour and the same place. So no, that's really good fun. It's Vertigo is quite a team at the moment, and they're being a huge support, and yeah, definitely.
They've always
Very
been really
adapted
talented
to
in
those
design
guys.
too.
Yes, so a couple of years ago we did this little pavilion together with Vertigo and Summum Engineering, and since that project sparked, we have been close friends ever since, and yeah, working together closely. Yeah.
So are those employees in the? Go ahead.
Yeah, so I'm really lucky to have such cool and intelligent friends in such close proximity. So I'm really fortunate with those guys.
Are employees with experience in materials and robotics the thing you need most right now to grow, or are you looking for financing, investment, partners, or projects?
Yes, that's what I need. What I'm the outlook most, and in a sense, not too many people. Let's say in already in the emerging field of 3D concrete printing, there's quite a bit of experience, right? And not all of that experience translates to my approach to earthen constructions, right? So it's let's say it's also fairly unique. I guess the work that comes close is maybe the work of Norman Haag, who has been pursuing shotcrete 3D concrete printing. So additive and Mobot are also pursuing that, and I'm also I think those companies are that it's pretty interesting their view on concrete printing. Find that interesting.
Does your system include a rotor stator anywhere?
No, not so much. No, it's the material flow that is challenging because we're addressing relatively big volumes. So a lot of transport belts, a lot of mixers, silos, those kind of aspects, and we managed to integrate the shotcrete apparatus already transparently with the robot. So that's the natural extension of the robot. And something that really helps in trying to achieve lights out production is that if anything goes wrong, if a print hasn't succeeded, you should just read the logbook and it should be very obvious what went wrong, right? So that demands this very high degree of integration, this kind of rigor to that kind of process. So in that sense, feels very much like a software engineering project, the way we approach this.
If it's a dry mix coming out of the shotcrete head, is there some kind of secondary spray or moistening process to make it adhesive?
So the dry mix is shot up until the nozzle, and then at the nozzle it mixes with the percentage of water. So in wet mix, no, just accelerant is added at the nozzle, right? And in dry mix, it's both, and the accelerator and the water. Yeah, and then the actual mixing, which is kind of interesting, is the impact once it hits the projected surface. That's your actual mixing process. It's kind of fun, right?
So it's fairly homogeneous to begin with.
Yeah.
And where are you getting the dirt from for these early projects?
You have a number of specialized firms who offer these ready mixes, and it's a question of divide and conquer, right? Is that that secures a constant supplies of more or less the same material, and I think when you're doing these initial steps of technology development, you want to rule out. You can't do everything simultaneously, right? So the material science we're we're trying to push that a little bit, push that out to some extent, because it's such an incompressible, challenging project. And in a sense, even at the scale of a house, you can't do much research on the material aspect of it, right? If you're starting to produce kilometers of sound wall barriers, that would be a game changer, right? And you can install a team that adapts the locally found source to the requirements that you need. So that's what's pretty attractive in earthen construction, is that although it feels somewhat revisiting an ancient construction techniques, as you stated, is that some of the methodologies involved are pretty high-end, right? A paper that I found very influential was that, the name of the researcher fails me, it's too bad. But there was an interesting paper that applied machine learning such that you can get away with a limited set of field tests to find out how to adapt the recipe, to get the properties that you're seeking, rather than going through a large series of costly and involved laboratory tests, right? And the mapping of us that was 95%. So it was incredibly impactful research. Yeah.
Very nice. Is there anything that we didn't cover that we should get to?
Well, next year, spring next year, we're building a prototype sound barrier wall, 250 square meters, 2.5 meter high.
Wow.
So that's a stretch of 100 meters. And so mobile robotics are pretty key in a pretty key ingredient, right? So we're not building these straight up walls, but then again, it's also not the most challenging design to produce. And in a sense, mobile robotics, it also introduces a number of challenges. So that's why we try to balance both that these sound barriers have a degree of sculpturalness in it, but also that we can pull it off on a technical level. And so the mobile robotics are a hot ticket. Yeah.
I think you already mentioned this, but 250 meters by what's the height?
250 square meters, so it's 2.5 meters high, and then 100 meters long. So that's quite a prototype.
And it'll be a sound barrier between like a road and a pedestrian area, or?
It's a prototypical sound barrier. So it's not adjacent to the railway. So it can fail in that sense. But the exact location hasn't been specified yet. So the coming months we're making a number of smaller panels, but that will be quite a challenge.
Yeah, I guess it will have to be a waterproof robot as well. If you're printing outside, it could rain.
Oh yeah. So the work in stone cutting is that you have ABB robots are very well waterproof, and you can just hose them down with a jet. It's fine. They're IP68. Yeah, and that's my kind of preferred brand of robots. So lucky me.
Yeah, cool. I should be in Eindhoven at some point in 2023, spring or summer. So I'll stop by and we'll do a video in person if you'll let me.
Oh, terrific. Jared, looking forward. Excellent.
Yeah, my plan is to be in Europe for 6 months at some point in the middle of 2023 to visit as many construction automation companies as possible. And Eindhoven is certainly a stop, without a doubt. So,
Perfect.
Yeah, that'll be awesome.
Okay, excellent. Good news. Something to look forward to.
It's a ways off, but you have a lot to build by then.
True. Yeah, yeah. Hopefully we'll meet all of those goals. It's actually I misspoke. The sound barrier prototype. It's in the spring of 2024. So we have
Okay.
a year and a half to get up to standards. Yeah.
Well, I'll come back again. I think it's kind of my job now to just go film all the different construction automation companies. So I hopefully will, every couple years, I'll be able to reach Europe, the Middle East, Asia, ideally. We'll see.
I wish I had thought of that business model myself. It sounds like terrific, but also I mean that's the joy and pleasure of pursuing the coverage of this revolution. It speaks from the channel. It's an important source of information. So that is much appreciated.
To be honest, I never thought of a business model. I was with a roommate of mine from college, traveling with his family in China, and WinSun happened to have a facility there. They let me tour it, so I bought my first camera and filmed the facility, knowing it's not easy for Americans to always go over there. Posted the video on YouTube, and it just got some views. And then another company printed near my parents' house in Long Island, so I found that house, filmed that, and after that, company started reaching out to me to film. And so it kind of just happened by itself. There was never a business model in the beginning.
It's cool though. I didn't know that history. It's interesting to
Yeah.
hear.
So I'll just keep doing it as long as I can. It's fun. So
It's interesting where our enthusiasm is taking us.
yeah, it's the best thing in the world is when you can have a job that you're enthusiastic about, right? So we're lucky in that regard. But I really
Absolutely.
appreciate you taking the time to talk with me today, Jelle, and hopefully we can do this again. Maybe if it's a podcast in person, if the sound barrier's not built yet in Eindhoven, or we'll figure me, you, and Volker can grab lunch or something. I'm looking forward to it.
I'm looking forward to it. Should be excellent. All right.
All
See
right.
you in Eindhoven, Jared.
Thanks again.